Hello children, welcome to EDUHUNT classes where you can excel your academics. In this particular video, we are going to solve regarding worksheet 3 bits with mains model. Okay, here we go. Let's start the session. Yes, here we go. So first question is for you. Generally, a base is a compound. Okay, we know generally bases are a compounds which something definitely you already know. Okay, so here we have ABCD. We'll see. Select what is the right option. Okay. Generally, a base is a compound, okay. Option A, which reacts with an acid to give salt and water. Oh yes, base reacts with acid to give salt and water respectively. That's called as which reaction? Neutralization reaction. Yes, true. Now, option B, which reacts with a proton of an acid. Yes, we know protons are nothing but the acid containing ions. Yes, the protons, they give they react with protons of an acid to give rise to again salt and water. This also option is right. Okay. Now C, which on dissolving in water furnishes OH minus ions. This is also true. So absolutely the option is D. All are correct. Okay. Because why? A base generally a compound which reacts with acid to give rise to salt and water, and which reacts with proton of an acid, and also which on dissolving in water furnishes OH minus ions as the only negative charged ions. That is also a base. Okay. So all the three are correct, ABC. So hence the D option is right. All are correct. Okay, children, as the first bit option, correct option is D. Okay. Now second question. Which of the following is or are correct? Okay. Option A, all non-metallic oxides are basic in nature. Children, did I say any term regarding non-metallic? I told you all metallic. No, metallic oxides I told you examples, and metallic hydroxides I told you examples. Did I use any word called non-metallic? No, right? So this word is not included in the particular basis. Okay. So option A is wrong, and all metallic oxides are bases. Yes. Examples, what are things? Ne2O, K2O, CaO, MgO. So all these are metallic oxides, and all metallic hydroxides are bases. Yes. Okay. So we'll move to the next option. What is it? D. Both B and C are correct. Yes. Both B and C are correct. So what is right option, children? Option D. Here also option D. C. Did you forget the concept? No. Okay. What are metallic oxides? Examples? Tell me. Very good. Na2O, K2O, CaO, MgO. So all these are examples of metallic oxides. What about metallic hydroxides, children? Metallic hydroxides. Give me the examples of metallic hydroxides one by one. Yes. Here it is Na2O, no? Metallic oxide. What about metallic hydroxide? NaOH. Yes, one more. KOH. Very good. One more. CaOH twice. Very good. One more. MgOH twice. Very good. Any more examples? Did I give you? Very good. NH4OH. Metallic oxides. Sodium oxide, potassium oxide, calcium oxide, magnesium oxide. Yes. Metallic hydroxides. Sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, and also ammonium hydroxide. All these are bases. Okay. So option D, both B and C are correct. Okay. Now moving to third question. A base which is soluble in water is called. Okay, direct statement. We have two bases, soluble base and insoluble base. So base which are soluble in water called as what? Called as alkali. Very good. Option C. It is called as an alkali. Alkalis are the soluble bases. Very good. Direct question, direct answer, direct statement. Okay. Moving to next question. Question number 4. Statement Y, statement A and statement B. Okay. Children, I told you, no, definitely I told you a point to remember. I gave you some important point to be remembered in the alkalis video. Yeah, I told you, no, that is being asked repeatedly in the statement wise questions, also in decision reason. Yes. Okay. Here we have the particular same question for you. Yes, all alkalis are, statement A, all alkalis are bases, yes. Statement B, all bases are not alkalis, absolutely true. Okay, now, okay, option C, both A and B are true. I give examples also. I give example regarding KOH and ZnOH twice, potassium hydroxide and zinc hydroxide. Potassium hydroxide is a base, zinc hydroxide is also a base, but potassium hydroxide dissolving in water gives OH minus ions, so this is called as an alkali, whereas zinc hydroxide does not dissolve in water and does not give any OH minus ions, so it is not called as an alkali, not an alkali. Okay, so here we have all alkalis are bases, but all bases are not alkalis. This is also base, this is also base, but this base is not a soluble, not an alkali. Okay, so all bases may not be alkalis because it may be insoluble bases too. Okay, children, moving next question. This question answer is C. Okay, enough. Okay, moving next question. Question number 5. Yes, which of the following base is not an alkali? Giving options: NaOH, COH twice, ZnOH twice and COH twice. Tell me what is the right option. Shall look carefully and do the sum. Sorry, do the problem. Do the question. See, we have 4 options. First one is NaOH. What is the name of the NaOH? Sodium hydroxide. Do you think it is an alkali? Yes, absolutely. Because why? When NaOH dissolving in water gives rise to, furnishes OH minus ions. So it is considered as an alkali. Then what about B? Copper hydroxide. Copper 2 hydroxide. What is the conditions? Do you think it is a alkali? Yes or no? Tell me. Okay, leave it aside. You don't know, leave it aside. Now, coming with zinc hydroxide. ZnOH twice. Just now it is not an alkali. It is a insoluble base. Insoluble base. Okay, now calcium hydroxide. This is also an alkali because why? Dissolving in water furnishes OH minus ions. This is also a alkali. But coming to the options B and C, if we consider carefully, copper hydroxide is also a insoluble base. Insoluble base. So here we have proper options 2 to be considered, that is B and as well as C. B and as well as C. Okay. So we have B, copper hydroxide, and C, zinc hydroxide. Both are considered as insoluble bases, which is also not considered as an alkali. It is not an alkali, it is a insoluble base. So both A and D, sodium hydroxide and calcium hydroxides, are alkalis, but B and C are not alkalis, which is termed as a insoluble base. Clear, children? We have 2 options. Look carefully and do it that. Okay. Yes. Moving to 6th question. Yes, here we go. All metallic oxides dissolving in water give. Okay, what is that? Metallic oxides dissolved in water give what? They give acidic hydroxides? No. Basic hydroxides? Yes. They give basic hydroxides. Because why? These are bases only, no? Okay, now 7th question. The degree of dissociation of an alkali in an aqueous solution is given by. Children, direct formula from the classification of bases regarding the strength. We have to know strong base and weak base based upon the degree of dissociation. What is the formula, children? Alpha, right? Degree of dissociation formula. We have the symbol representation alpha. So what is the formula, children? A, B or C or D? Okay, D is not required. None. Okay, A, B or C? Very good. Option B is right. Because why? Into 100. Here they gave in the denominator. Here they didn't give any into 100. So that option is B. Number of dissociated alkali molecules by total number of alkali molecules into 100. So multiplication is necessary for that. Okay. So we have the constructed grading. 7th bit option is B. Direct formula. Okay. Mathematically we told you no. Alpha, degree of dissociation, gives rise to the strength of an acid, strong base. Strength of a base. Okay. Yes. Now moving to 8th question. Which of the following is a strong alkali? Okay. Strong alkali. We have alkalis. Strong alkali as well as weak alkali. So what are termed as a strong alkali? Come on, tell me. Strong alkali. The strongest one. Very good. KOH. Why, ma'am? Why not like that? Others also there. No. Tell me. See, we have particular periodic table. In that we have group 1, group 2. Okay. So in that group 1 are called as alkali metals. Group 1 are called as alkali metals and group 2 are named as alkaline earth metals. Alkaline earth metals. Okay. So here we have group 1 name, that is given no alkali metals, is alkaline earth metals. So here we have alkali metals conditions of sodium hydroxide, potassium hydroxide, lithium hydroxide, all cesium hydroxide, all this comes under alkali metals. Okay. What alkali metal hydroxides, and what about this alkaline earth metals group 2 in the sense? Calcium hydroxide, magnesium hydroxide, all these are there, no? So in that condition we will write an important point over here, which is group 1 hydroxides are very strong, They react with water and they give furnishes OH minus ions directly. Okay, these are very strong, and comparatively with group 1, group 2 are just strong. Okay. So here the particular options we have A, B, C and D, right? So magnesium hydroxide coming under group 2 we have here. Okay, it's strong. Yes, it's strong. And option B, NH4OH. Children, this is weak alkali, children. Weak base we can say. Okay, it is a weak base. Okay. And coming with COH twice, calcium hydroxide is a strong but not compared to that of alkali, because we have other option KOH, no? So we have to go with the particular KOH, because why? Group 1 metallic hydroxides are very strong than the others. Okay. This is weak alkali, NaOH is weak alkali, and comparatively with that option is D, because he asked a strong alkali, no? Yes, that's the reason we are going with option D, that is KOH. Okay. Now moving to next bit. Okay. Na2O is a, children, come on, tell me. Right question. We have metallic oxides, no? The first example is this one, Na2O. That is a basic oxide. Okay. Option is B. Very good. Na2O is a metallic oxide. We know all metallic oxides are bases. Okay. Now moving to next question. Okay, the last question. We have matching column 1 and column 2 over here. So let's find out. We have 4 PQRS, zinc hydroxide, calcium hydroxide, aluminium hydroxide and potassium hydroxide namely. Here we have 1, 2, 3 in column 2, strong alkali, amphoteric alkali, weak alkali. Okay. Children, you know about strong and weak, but you ever know about amphoteric? Amphoteric in the sense it acts as both acid and as well as base. That is amphoteric. Okay. Now ZnOH twice is a, we know it is a weak alkali. Yes, weak alkali. 3. Now we have options 3 over here. Okay. Calcium hydroxide, it is also a weak alkali only. Okay, comparatively calcium hydroxide is a weak alkali. Zinc oxide, zinc hydroxide is an insoluble base, but here we don't have any such options, so we'll go with weak alkali, okay. And aluminium hydroxide, it is a amphoteric, it acting as a base and acting as an acid based on the particular reaction, okay. It can act as an acid as well as a base. That's the reason it is called as amphoteric alkali, okay. Now, we know potassium hydroxide is a strong alkali, 3, 2 and 1. So, option A is matching, okay. Children, I told you, no, zinc hydroxide is insoluble base, I told you, no. But you don't have such options regarding insoluble base, so I am going with weak alkali. In the sense, it is not at all strong, it is a weak alkali. What is this? Zinc hydroxide, okay. And calcium hydroxide also a weak alkali, okay. And aluminium hydroxide is a amphoteric alkali, which means that acting as base and as well as an acid particular reaction. And KOH is directly a strong alkali, okay. This is all about the particular matchings, 3, 3, 2 and 1. We'll go with option A. Clear? This is all about the 10 bits from the mains model of the worksheet 3. Okay. Thank you.